Hello everyone, welcome to this lecture of the course Digital Electronics and Circuits. And in this particular lecture, we will be talking about what are digital systems, what are the advantages of systems, what kind of digital circuits are present, what kind of processing elements, storage elements, and display elements are there in digital systems. And then we will be briefly going over the course outline. Sure. So to begin with, right? So whenever we talk about systems and signals, right? What is a system and what is a signal, right? So basically, it's important to understand what kind of systems are there, what kind of signals are there, and how do we categorize them, correct? So to begin with, right? I would say like there are two kinds of systems, right? One is a digital system, one is an analog system. Similarly, there are two kinds of signals. The signals will be discrete signals and a continuous signals. Sure. So first of all, we need to understand this concept of signals and systems before we make further inroads into digital electronics course, right? So just to mention, so we have two concepts over here. One is signals and one is systems, right? As I said, signals are of two types: continuous and discrete. And systems are of two type: digital systems and analog systems. What we will be discussing in this course is entirely digital systems, but it's important to understand what each and every term means, right? So basically, when we say that we have two kinds of signals, continuous signals and discrete system signals, right? So basically, whenever we talk about continuous versus discrete, it is with respect to time. And whenever we talk about digital and analog, right, this is with respect to value, right? So if I draw x and y axis graph over here, okay, x, let's assume x is represents time and y represents value. When I say a signal is continuous signal, it means the signal has a value throughout the time durations, throughout for over across the entire time stamp. It will have some value. Whenever I say the signals are discrete signals, right? Signal will have value at some particular instances of time, not at throughout the time duration. Similarly, when we say that system is a digital system, right? The system will have discrete values. Okay, it will have some level value, say 1, level value 2, level value 3. Whereas analog system is the one which will have a set of continuous values. It could have a value of 1.1 or 1.2 or 2.1 and so on, right? So basically what we need to understand over here is there are two kinds of signals, two kinds of systems. What we would be talking about mainly in this course is digital systems. But just to give you an example of what would a particular thing look like, right? Let's assume I draw something like x-axis and a y-axis. Now if we have to plot something like a digital continuous systems, what it would mean is a particular signal has something like this. So let's assume this is value, this is time. So basically, how do we say that what kind of signal it is? This particular system has only discrete values. It can take a value over here which is 0 and say this is a value L1. Similarly, let's say this is a value L2, right? So this particular system is taking only discrete values. So basically, we will say this is a digital system, correct? And whenever we look at the time duration, we see that this signal has values at all instances of time continuously. So this is a digital continuous signal, right? And just to talk about this concept a little more, right? So basically, let's draw one more example over here, right? Uh, let's assume this is a x-axis, this is a y-axis, this is value, this is time. Mm, let's draw an example. what kind of a signal and system it is. So basically one thing is we know that this has a particular value, right? And that value is like a not a continuous set of values but a fixed value, say L1. So basically this is a digital system, and but does it have value at all instances of time? No, it has value only at particular instances of time, say t1, t2, t3. This is digital system and it's like a discrete timestamp. So this is digital discrete. So we will call it digital discrete. Similarly, right now, if you have to talk about one more system over here, the same thing over here, like this is a y-axis, which is like a value, and similarly, this is x value, x-axis, which is like say time. And now, if we have something like say a signal, let's assume a sine wave is there, right? So basically, let's assume this is level 0, this is value 1, this is value -1. So basically what is happening, this particular system is having values throughout this interval from 0 to 1. It could have a decimal value of say 0.45, 0.712, right? So basically we will say this is analog system, and it has a values at all instances of time. So basically if it has value at all instances of time, it will be a continuous, analog continuous, right? So I am assuming this particular concept of signals and systems is clear, because this will be the underlying basis for our course on digital electronics. Fine. So signals are of two types, continuous and discrete, and similarly systems are of two types, digital and electronics, digital and analog, sorry. And in this course, we will be talking about digital systems in continuous and discrete time frame. Correct? And basically moving ahead, right? Okay, why are we doing this course on digital systems? Like, what are the, so basically, if I ask you, like, what are the advantages which digital systems presents us over analog systems, right? There must be some advantages due to which digital systems are so famous, digital circuits are so famous, right? One is just to mention that, right? One basic advantage of digital system is reproducibility of results. So when I say reproducibility, right, basically what does that mean? So as we saw, or as we spoke about it, right, digital signal systems will have some set of values which will not be continuous but discrete, right? Let's, like, usually when we say we have a binary number system, right, which all of you might be knowing, it's either a value 0 or a 1. This is like a digital system, correct? So basically once we are dealing with zeros and ones, or for decimal numbers for that matter, right, where we have say something like 0, 1, 2, up to so on to 9, we have something called as a reproducibility of results. What we can do is when a system is operational only in the mode of zeros and ones, if we have to trace some bug or trace some failure, it could easily be retraceable, because we have only finite set of values 0 and 1, in contrast with analog system which could have continuous values, infinite number of values between 0 and 1, be it 0.001, 0.011, right? So reproducibility of results is one of the main advantages of digital systems. And the second one, which comes as part of reproducibility, is like ease of design. It's easy to design systems when we know that we are only the system can attain a finite number of values, say 0, 1, 0, 1, 2, or in hexadecimal 0 to f, right? So basically ease of design and programmability is something which digital systems are, for which digital systems have advantage over analog systems. The one of the next other point is speed. We will be talking about this speed in details when we talk about CMOS circuits, right? So digital circuits are much faster as compared to analog circuit. And when we talk about CMOS, we will talk about a lot of things regarding power dissipation, and basically and something on terms of cost also. It's like cost associated with development of digital circuits is much lesser, and it's preferred over analog ones. And then at the end we will talk about something called as integrated circuits as well, ICs, which are built using digital designs, right? So these are the major advantages of using digital systems, one being reproducibility, then being ease of design and programmability, associated speed, cost, and use in integrated circuits, right? So now moving ahead, right? So whenever we talk about digital circuits, there are two kinds of digital circuits. One is called combinational and other is called sequential. We will be looking into, we will be doing a deep dive into each of these circuits when the time comes and as and when we proceed in the course. But just to mention it briefly over here, right? Digital circuits could be of two types. It could be combination, it could be sequential. Combinational is something where we say that output of a circuit depends only on present inputs. All right. Sequential circuits are the circuits where output depends on, it's a factor of present plus previous input. All right. So basically when we say, okay, we say that, okay, for combinational circuit, output is directly proportional to or dependent upon the present input, right? This means that whatever is the input, depending upon the input, your output would be reflected. In case of sequential circuits, we have something, we have some complexity over here where we say output depends not only on the present input but on the previous input as well. If a circuit has an output, present output, which depends upon previous input, it simply means that it needs to have some sort of memory and timing element. Correct? Basically, circuit is able to store into its particular memory that what kind of a value the system, the previous input had, right, for the output to be dependent upon the previous input and certain sort of timing constraints. So we will be looking deep into all these things, like what is memory circuit element over here, what is the timing constraint over here, and what further circuits are form of are part of combinational and sequential logic. Just keep in mind that digital circuits are of two type, combinational and sequential. Now, right, going forward, just to mention few more terms when we talk about processing elements. Let's assume that we have concept of, like, say, let's assume that we have some arithmetic circuit. What is an arithmetic circuit? Say a adder, multiplier, right? All the circuit which perform arithmetic for us, right? We have something called as decoders. Similarly, we have something called as encoders, and we have something called as muxes and demuxes. We will be talking about all these circuits and all these processing elements in this course, just for the sake of listing few of them so that we have a basic idea of what we will be talking about in the course. Like if you have to say that what all processing elements could be possible in a digital circuit, we could say, okay, arithmetic circuits being like an adder or a multiplier is an example of a processing elements. Then certain set of decoders and encoders which are used extensively in communication networks, they are also a processing elements. And then muxes and demultiplexes. And if you remember previously we talked about sequential digital systems, right? And basically we spoke about a concept of memory and timing. So basically concept of memory, we will be talking about certain storage elements which can store the value of the previous input based upon which the present output will be dependent. And we have certain set of storage element, you would be hearing this term pretty frequently in this course, which is known as flip-flops. Then we have a RAM, random access memory, ROM, read only memory, right? We have registers, and then we do have something called as counters. We will be looking at all these storage elements, and then eventually we have something called as display elements also, right? And display elements consist of what? LEDs and LCDs. Now if you think about it, right, why I am talking about all these kinds of an elements. Basic computer system, when we talk about computer organization, a basic computer system consists of what? If you would recall from your basic classes, right? A particular computer system has something called as arithmetic logical unit ALU. Then basically this is like a control unit CU. There's a concept of memory, and we have set of input blocks, and then we have a set of output blocks, right? And we basically say this particular ALU plus control unit together forms a CPU of a computer, correct? So basically all the processing elements, all your ALUs and CUs, all your arithmetic circuits, they are all digital circuits, right? So basically we will be reading about all these CPU elements. Then we will have concept of memories, basically storage elements. Your input and output is basically how do we interact. We have set of screens, display monitors, right, which are LEDs or LCDs based. This is what we will be talking about in this course in detail as well, correct? So basically just to recap once again, right, what we will talk about in this course is a set of combinational circuits, which are nothing but these processing elements, and which is like arithmetic circuits, decoders, encoders, muxes and demultiplexes. Then we will be talking about sequential circuit also, just to put a name to it. Sequential circuits could further be of two types, which I will be talking about later: synchronous or asynchronous, right? And after this we will be talking about certain set of digital ICs, like what kind of integrated circuits are there, like TTL, transistor logic, CMOS, complementary metal oxide semiconductors. We will talk about few memories, and this is how our course outline would look like, correct? And yes, so basically this is something which I intended to cover in this particular lecture as to what is the beginning of this digital electronics and circuits course, signals being of two type, systems being of two type, why we look into digital systems, what is the importance of digital systems, why would we talking about digital systems in this course. These are the few advantages of those particular digital systems. And then we spoke a little bit about digital circuits being of combinational type and sequential type, sequential circuits being of synchronous and asynchronous, which we will be discussing in detail in this course. And they have a element of memory and timing. All the processing elements like arithmetic circuits, decoders, encoders, and multiplexers are nothing but combinational circuits. And we have set of storage elements like flip-flops, registers, counters, RAM, and ROM, which are nothing but sequential elements. Then we have static elements like display elements, LEDs, and LCDs. And this is all for this lecture. Stay tuned to this course for more interesting lectures.